Hello and welcome to Math World. Today we're going to go over the Unit 2A test. Alright, so the test gave us this parabola and asked us to basically describe it in all the different ways like we would in a graph battle. Alright, so first is the vertex, and we know that the vertex is the lowest point or the highest point. In this case, the lowest point right here. Now to give full credit, you had to correctly identify it as 1, negative 4. It's an ordered pair. 1, negative 4. The zeros of the function are where the parabola crosses the x-axis, which is negative 1, 0 is one of them, and the other one would be positive 3 and 0. Let's use a lighter pen here. Alright, now that I have the zeros, I should be able to write it in factored form. Factored form being f of x equals, and now I just need my two parentheses. X opposite of minus 1, so plus 1, and then x opposite of positive 3, negative 3, or minus 3. There's factored form. Alright, so far we got 1 point, 2, 3, and I split this one up as 4 and 5. And let's go to vertex. Using this vertex up here, let's write it in vertex form. Vertex form should be f of x. And now we need x minus that x of our vertex, so x minus 1. Square the parentheses, and then throw on the y of our vertex, minus 4. So there you go, another 2 points. 1, 2. How you doing so far? Domain, that's an easy one. Almost everybody got this one right. Negative infinity to positive infinity, or all real numbers. This thing goes infinitely from left to right. But up and down the range, not so much. It starts at negative 4 on the range, and then it goes up infinitely, so it will be from negative 4 to infinity. So those are each worth a point, and let's move on. Now this is where it gets a little bit tougher. The axis of symmetry, it seems like we're still having a little bit of issue with the axis of symmetry. The axis of symmetry is always going to be x equals, and it's x equals whatever the x of our vertex was, and our vertex was at 1. Remember, the axis of symmetry is this line going through the parabola, splitting it in half, right at 1. So it's x equals 1. What is the y-intercept? Most of us got y-intercept as 0 and negative 3. It's where the parabola crosses the y. Alright, now the intervals we still have a little bit of trouble with. Intervals, remember, are measured on this x-axis. So this parabola decreases on the x-axis way back here, from negative 3, negative 4, way back infinitely negative. And it comes from the negatives all the way, keeps going, until when does it stop decreasing? Right here, right at the symmetry. See how it goes down, and now on the x-axis it is no longer decreasing, so we'll say the interval of 1, from negative infinity to 1. And then so the interval of increase will be from that point on, 1, until further notice, until infinity. So from 1 on to forever. And then lastly, the average rate of change. This one gave us some troubles. The interval negative 1 to 1, that means negative 1 on the x-axis, this point right here, and positive 1 on the x-axis, this point right here. We'll change colors. From negative 1 to positive 1. Alright, that means this point here is negative 1 and 0, and the other point is positive 1 and negative 4. I had to choose those 2 points to find my rate of change. What's the change in my y's? It went down 4, and the change in my x, it went over 2. So rise, -4, run 2, that is a rate of change of -2. There you go, there's the average rate of change. This page, after I give you points for all these, was worth 14 points total, was the best you could do on this front page. Alright, now the back page, we had, this problem was pretty simple for most people. We put it into the calculator and just followed a table. The table said that after 2 seconds, it would be its highest point of 64. So you had to understand that the highest point was the vertex and how to find it on a table. I think everybody got that, 2 seconds. When will it hit the ground? Well, that would be when y is 0, and most of us figured out that it was 4 at 4 seconds. Not so much the first 0 of 0, 0, but at 4 seconds it was on the ground again. The ball lands on the ground. So if you had said something about a table, or maybe even plugging in 4 into the equation to get 0, anything like that would be worth points. And lastly, at 3 seconds, again, the table told us at 3 seconds the ball was at 48 feet. So you should have labeled it, said something about a table, or even said putting it into the equation. 64 times 3, I believe, is 196. And then 16 times 3 squared, 3 squared is 9. 16 times 9 is, where's that, 144. And 196 minus 144 is 48. So it works that way too. The last problem was our transformations. We did pretty decent with this. We should have been a little more specific about the transformations. The negative makes it reflect. That was kind of easy, but you couldn't just say it's upside down. You had to use the word reflection. The 2 made it dilate. And you maybe should, did I spell that right? Dilate. Dilate or dilation. You should have said dilated by a factor of 2 because of the 2. And lastly, this -3 on the outside of the square is a vertical translation. Vertical translation. Some people put horizontal. It is going up and down. It's actually going down 3. You couldn't have said, if you said reflection translation or dilation translation, that's kind of a mix-up of the vocabulary, so I took off a little bit of points there. But reflection, dilation, vertical translation. This was worth 3 on the top, so 6 points on this page, for a grand total of 20. Well, that's the test, and hopefully that helps you out. I'll see you in class.